Hello folks, the problem for today is this one. So it is also again concerned with the compound microscope. So I'll be dealing with a series of problems related to certain chapter, and then I'll switch to another topic or another chapter. So this is about compound microscope once again. So it says a compound microscope with magnifying power 42. So it says that the magnifying power is equal to 42 is to be constructed from two convex lenses of focal length 2 centimeter. So this f1 is equal to 2 centimeter. In a compound microscope, generally the objective has the shorter focal length, it's more powerful, to 2 centimeter, and then the eyepiece has got 5 centimeter. Calculate the length separation if, so I wrote if twice, not necessary, if the least distance of distinct vision is 25 centimeters. So it means that the nearest image distance possible is equal to 20 centimeters. So it is formed by the final lens or the eyepiece lens. So that's why it should be V2 is equal to 25 centimeter, and that's minus because the final image formed by compound microscope is a virtual image, and that virtual image is formed at 25 centimeters. So we have to adjust our eyes, the lenses in such a way that the virtual image is formed at 25 centimeter. So let us go to the setup of this thing. So we have, this is the objective lens and this is the eyepiece lens. So this is the principal axis. The object will be somewhere around here. The first image will be somewhere around here, and the image distance. I don't know where it will lie. So just imagine that it is over here. So this image is formed by the second lens, which I say as L2. So this is L2, L1. This distance is U1. This is the object distance for the first lens. This distance is V1, image distance for the first lens. So this distance is the object distance for the second lens, and this distance is equal to the image distance for the second lens. So among these things, what we are given is, we are given this thing. So this is equal to 25 centimeter, and all others that we have to find out. So what we can have here is, so from f2 and v2 I can have u2. So for the second lens, we have from f2 and v2 I like to find u2. So u2 is equal to v2 f2 divided v2 minus f2, the combined formula, the final formula actually. So that's equal to minus 25 into 5 divided minus 25 minus 5 equal to minus 125 divided minus 30. So its value will come out to be equal to, let me use calculator. So 125 divided 30 equal to 4.166 and so on. So this value is equal to, it comes to be positive, so it is 4.16666. So I write it as 4.2 centimeters. 4.2 centimeters. This is U2. So it is 4.2 centimeter. Now we have given the magnification here. So we have got this U2 and we have got magnification. So what we have is the total magnification is the total magnification is equal to this m is equal to magnification of objective into magnification of eyepiece. So magnification, it goes by number of times. So this number of times into this number of times equal to this much. So like that. So which gives us or 42 is equal to this m1 is equal to v1 by u1, or I can write it as this m1 is equal to let us say just write m1, this is m1, and m2 is equal to, so this m2 is equal to v2 is equal to v2 by u2. So this will be equal to m into v2 is 25, and this is equal to 4.2. So this gives us, so therefore this m1 so m1 is equal to so 42 into 4.16666, actually 4.166 divided 25 is equal to 6.99. So it is equal to equal to 7. So the magnification of the first lens is equal to 7. Now it will give me, so I need V1, so we have got M1. So this M1 is equal to V1 by F1 minus 1. So magnification is equal to V1 by F1 into minus 1. So that's equal to V1, we have to find out V1. F1 is equal to 2 centimeter minus 1. So that's equal to V1 minus 2 by 2, which gives me, so I've got this is 7 is equal to this much. So 7 into 2 equal to V1 minus 2. 7 2s are 14. This 2 comes here, plus 2. 14 plus 2 is 16. So this gives us V1 is equal to 16 centimeter. So V1 is equal to 16 centimeter from the calculations. So this is 16 centimeter. Now what I define is the lens separation. So separation of the lenses. So separation of the lenses is equal to, as you can see from here to here, it should be magnitude of V1 plus U2. That is equal to V1 is equal to 16 plus this U2 is equal to 4.2, which gives me 16 plus 4 is 20. So it is 20.2 centimeter. So the lenses are separated by a distance 20.2 centimeter from all our calculations. So this is the answer for this.